Hello class, welcome to our lesson today dealing with measures of variation. The last class periods we dealt with measures of center. Today we're going to look at the measures of variation, which is the second piece that's needed to start looking at statistics a little bit closer. First thing we're going to look at in terms of variation of data is the range. So the range is the one you're probably going to be most familiar with and you've seen before from all the pieces that we're going to look at today. The range, remember, is the difference between the highest and lowest numbers. And so when you find that, you just find the maximum number, find the minimum number, and subtract them. And that will find the range of the data as you're looking at the situations. The next thing is what's known as standard deviation. Now, this formula is going to look a little confusing. We'll look at an example real quick on the next slide. This is the amount of variation. Okay, it's a measure of the variation between the values and the average or the mean. It is denoted for samples by the letter S. You'll probably notice I have a bad habit of using SD for standard deviation, mainly because my S's and 5's look so similar to one another. But that would be used for the standard deviation as well. The standard deviation is this formula, and it looks kind of crazy, but it's sigma adding up the difference between the x and the mean, the values of the data points and the mean, square them to make sure that all of them become positive, and then divide by n minus 1. It's n minus 1 and not n here. You would think it'd be like find the average and divide out, okay, just like what we did for finding the mean. It's n minus 1 because we're not as confident. This deals with something known as degrees of freedom. We'll talk a little bit more about that in the semester as we progress through standard deviation topics. But in general, what you want to look at is how do I find the standard deviation? The second one is the same formula, just algebraically things are moved around. The second one is more useful, especially before technology was readily available to find standard deviation. So this version, we're going to look at a question on one of the last slides, either today, I think it's on the next lesson though, where that's the only scenario where you're going to have to find everything by hand. In general, you should be able to find everything using StatCrunch or some type of utility. But we'll talk mainly about StatCrunch because that's what your homework looks at for these situations. Okay, just to kind of prove what standard deviation is looking at, I'm saying find the standard deviation of 4, 7, and 13. So the first thing is find the average, so I add those together and then divide by 3, and that's 8. And then the formula was x minus x bar squared. So add up all of the distance or the difference between the number and the mean. So 4 minus 8, my first data point was 4, and square it. 7 minus 8, square it. 13 minus 8, square it. And then divide by 3 minus 1, which is 2. I divide this all out. This one works really nicely because of the way the numbers were set up. And I get root 21, which is around 4.5, 4.6. That number's not going to mean a whole lot to you necessarily, but as time moves on, we'll be using the standard deviation to help find answers for different situations. Next thing to look at is population standard deviation. What you'll notice, population standard deviation is denoted by the Greek letter sigma. It's kind of a circle with a line on the end at the top. The formula is the same, except instead of divide by n minus 1, it's n, because we're actually more confident in what we're talking about. And so we can have a little bit more disclosure when it comes to a population because we've asked everyone the question. We'll probably be dealing with S more than sigma, since we're looking at samples a lot more than populations. But just realize that there's two different formulas and they're slightly different as we're trying to solve these questions. Variance is just the standard deviation squared, so S squared or sigma squared, depending on if it's sample or population. The variance is a good indicator. A sample and the population should be a good estimator of the sample should be a good estimator of the population for a variance idea. The main problem with variance is since it is squared, the units have to be squared, so it doesn't really work well as we're dealing with those scenarios. But it's used in certain formulas. For now, all you have to do is know how to find it. You don't have to know anything else really about the variance. It's not going to be very applicable right now. So as long as you can find the number, that's what's most needed for variance questions. When we compare variation, we have to make sure, for comparing standard deviations, for example, that the means of the two samples are close to one another. So if they're close, then we can say, oh, well, my average is about the same. Is there more variation? So the idea would be like in a class, two different classes have the same average, but one class has much more variation than the other class. So that might be something that shows up from time to time, and we're going to be looking at that more and more, and that's kind of the main application of what we're dealing with. If the samples are not close in average, then I really can't compare them. So if one class average has an 80%, the other class is a 60%, it doesn't matter how varied the data is. There's clearly a difference between those two things. And so I really can't compare the variation very well for those two samples. Okay, when you're asked to find range, variance, and standard deviation, it should be using technology to help find it. You should not be plugging in and doing it the long way like we did that first question earlier today. What you want to look at is plug the data into StatCrunch and then just do stat, summary stats columns, and it hit compute, and it should spit out everything you need. It should give you the standard deviation. It probably won't give you variance and range all the time. You should be able to find that using the max and min or squaring the standard deviation. You're going to have to play around with it a little bit and make sure you make some notes about, okay, this is what I need to do to plug things into StatCrunch. The other thing is a lot of your questions have data sets already made. You should be able to click a kind of a double rectangle in the corner, and that should input the data so you don't have to type it in yourself either. So really, we're more using the technology and then taking that technology information and then applying it to our situation. The standard deviation, variance, and range are shown here. If you want to try that out to make sure you know what you're looking at when it comes to this situation, I would recommend it to make sure that you can find the answers for the standard deviation especially. Okay, as a general rule of thumb, let's start with the second bullet point. An estimate for the standard deviation is the range divided by 4. That should only be used if there's no data to go off of, which is rarely the case. So in general, you don't want to use that. You want to use the circled one, which is considering what's usual or the normal group. And the minimum is always the mean minus 2 standard deviations, and the max is the mean plus 2 standard deviations. And the reason for that, which we'll see on the next slide, is a lot of the data, most of the data, is going to be within 2 standard deviations. The idea of this is similar to if I go to the doctor and I get my blood pressure drawn or blood pressure taken. If I'm in this normal realm for my age group, they're probably not going to have a big discussion with me. But if I'm outside that range, I'm going to have a discussion about, well, what's going on? What should I do with my with this number? But there's a normal range, and then there's everything outside that range, and that's what we're going to look at. Okay, so this is what is in general happening and why we can use 2 standard deviations as our approach. This is a bell-shaped curve, and this is the information for a normal distribution. Here's the average right here in the middle. If I go 1 standard deviation both ways, 68% of all the data is within 1 standard deviation. You may ask, how do they even figure that out? Well, this is a calculus question about area under a curve, and it'll be 68% of this whole curve will be in this area from 1 standard deviation. If I take that to 2 standard deviations, all of a sudden I've added enough, and notice most of the data, most of this green graph, if this was an area, is underneath that between 2 standard deviations. And it's 95%. And in general, 95% is a pretty good amount. If I said, hey, 95% of us are within this realm, and if you're the 5% that's outside that's unusual, okay, we can describe that and explain that. If you want to be really specific, like say you're a new pharmaceutical company and it's a drug or something like that you're trying to push out to the public, you may have to be more precise. And if something like that were to occur, you could go 3 standard deviations. And if you get to 3 standard deviations, 99.7% of the data. Look, there's just a little sliver on both sides that's left over. In general, though, we go 2 standard deviations for our approach. If there's a reason to go more, they will tell you so. But that's why we use 2 standard deviations, because it's within the realm, okay, of 95% of the data. And unusual data would be the 5% outside of that. Standard deviation is useful because the units are the same. If you want to compare standard deviation, if one data set has a small standard deviation and another one with the same mean has a larger standard deviation, there's more variation to that data comparatively. We can compare things very quickly with technology now than what we used to be able to do, say, a couple generations ago. And so that's also very useful as we look at standard deviation. Okay, that's everything I have for today. When you're looking at your homework, there may be a few ideas that we haven't talked about yet. We'll look at it in the next lesson. But there's a formula for something called coefficient of variation that you could find. The same setup is true. Do stats, summary stats columns, find the info, but then there's a formula to plug in to make sure that you can find some of those answers. Have a good day, everyone.